In this video, we're going to look at finding the volume of a square-based pyramid and a triangular-based pyramid. Here's a picture of each. We've got a square-based pyramid and a triangular-based pyramid, or a tetrahedron. With your square-based pyramid, you might get a rectangular-based pyramid. Either way, the formula will be the same. When we're looking at finding the volume of each of these shapes, we can say the volume, V, is going to be 1/3 of the area of the base multiplied by the perpendicular height. The perpendicular height is now at 90-degree right angles with the base. So this is the formula that we would use, and we would give our answer in units cubed. So it might be centimeters cubed, meters cubed, miles cubed, kilometers cubed. It's something cubed. So let's have a look at the square-based pyramid. So what we have is the base, and the base now is made up of these four sides like so. So we would find the area of this base, we would multiply it by the perpendicular height, which we'd be given. The perpendicular height is now straight up, like so, and we would divide our answer by 3. With the triangular base pyramid, we would do exactly the same. We would find the area of the base, so that's the area of a triangle, and we would multiply this now by the perpendicular height, which is this height just here, and divide our answer by 3. Let's go ahead and look at a couple of these, and I'm going to draw some shapes. So what we'll do is construct a square-based pyramid, which is going to look something like so, and then we will look at finding the volume of this. So let's say we were told now that each side, and I'll just show that each of these sides is the same, each of these sides is 6 centimeters. So if we were finding the area of a square with now side 6 centimeters, it would be 36 centimeters squared. I'm now going to go ahead and construct this and put some sides on. So we've got these slants, and we'll put them looking something like so. So this isn't necessarily massively accurate. It's just giving us a rough idea of what this square-based pyramid is going to look like. So something like that. And what we're now interested in is the perpendicular height. The perpendicular height now is the straight up height just here. It's from the base to the top. So let's say that this height we were given, and that height was, let's say, 5 centimeters. So if we want to find the volume, what we can do is say that the volume is going to be 1/3 base times by height. If we got 1/3 BH, this means 1/3 multiplied by the base multiplied by the height. Generally speaking, in algebra with these formulae, we don't put a multiply in. So what I'm going to have then is the following. I'm going to have 1/3 multiplied by the area of the base. Well, the area of the base is 6 times by 6, which is 36. So we're going to have 36, and we're going to multiply this now by the perpendicular height, which is 5. Our answer is going to be in centimeters cubed. So 1/3 times by 36 times by 5 should give us now 60. So 36 divided by 3 is 12. 12 times by 5 is going to give me 60, and that will be centimeters cubed. So that is the answer to my question. All I've done here is simply found the area of the base and multiplied it by the perpendicular height. In some more tricky problems, you might have to find now this height given one of these slants, and we would use either Pythagoras or trigonometry to do that. In this video, we're just going to look at basic examples of finding the volume. So let's draw one of these up. We'll draw a tetrahedron up, and it'll look something like so. So remember, these aren't accurate. I'm just simply putting now on the values. So what I'm going to do is say that we have now this height just here, and we'll have this one just here. So this is now the base, and let's say that this is going to be, let's say that that is 8, we'll say that that is 8 meters, this is 6 meters, and then I'm going to build this up. So what we'll have on here now are the sides, so let's just do something like that. Again, not massively accurate, but it just gives us some idea of what we've got. And I'm going to put a perpendicular height on this, and if I do that, let's put the perpendicular height. We'll say that that perpendicular height is going to be 7. So let's put that on, and that is going to be 7 meters. So the first thing I want to do is find the area of the base of the triangle. So this now has a height of 6 meters and a base of 8 meters. So we would do now the volume, I'm just writing this down, the volume is equal to 1/3 of the base times by the perpendicular height. So if I look here now at the base of the triangle, it's going to be 1/2, as when we're doing a triangle, it's the base times height divided by 2, 1/2 times by 8 times by 6, which should give me 24 meters squared. So that is the area of the triangle on the bottom. So for example, if we were using this one now, it's probably slightly easier to see. What we'd have is this area right here, and this is our base. So I've just found that in this particular case to be 24 by doing 8 times by 6 divided by 2. What we're now going to do is simply write this out. So it's going to be 1/3 times by the base, which is 24, multiplied now by the perpendicular height, which is 7. So this is at right angles with the base. It's not one of the slants, it's at right angles. So multiplied by 7. That looks like I'm going to end up now with 56. So that will be 56, and the units are going to be meters cubed. So all I've done is 1/3 of 24, which is 8. 8 times by 7, that's 56, and I've given the correct units, and it's 56 meters cubed. So that's well, a couple of basic examples of now a square base pyramid and then the triangular base pyramid or tetrahedron. If these lengths were different, we would simply find the area of a rectangle, multiply it by the height and divide it by 3. Okay, we're asked to calculate the volume of a 12 centimeter square base pyramid with a height of 20 centimeters. So if I just did a quick sketch of this, let's go ahead and do that. We'd have something that looks like this. Again, this doesn't have to be massively accurate. I'm just going to go ahead and draw a quick sketch, and we can put some dimensions on. So what we've got then is our base. Our base is going to be a 12 by 12. So this is 12, this is 12. So what we'd have here is 12 times by 12, and then that would give us the area down here. So all of this is going to be 144, and that will be centimeters squared. We've got a height of 20 centimeters. So if I go ahead and put the height on this, that is the perpendicular height, and that is going to be 20. So if we put this on, this height right here is now from the base to the top just there, that is going to be 20 centimeters. So all we're going to do is simply write out that this is going to be, now the volume is 1/3 times by the base, which is 144. And then from here, we're going to multiply this by the perpendicular height, which is going to be 20. All of these are in centimeters, so we can now give our answer in centimeters cubed. You can, of course, do this on a calculator. Otherwise, if you're comfortable with 1/3 of 144, this is going to give me now 48 times by 20, which is going to be now 960, and that will be centimeters cubed. So I found the area of the base. It's a square base pyramid, 12 by 12, multiplied it now by 20 and divided by 3. In this one, we're asked to calculate the height of a 4 centimeter square base pyramid whose volume is 40 centimeters cubed. So this time we're missing the height. So if we sketch this up, again, little sketch, you certainly don't need these, but it might help out. And then if we put now on these, like so, this is going to be our square base pyramid. So this time we're given the volume and we need to find this perpendicular height, which we can put on just here. So let's go ahead and look at this. So what we've got here now is the following. This is the base. The base is going to be 4 by 4. So this is 4 centimeters. 4 by 4 is going to be 16 centimeters squared. We're going to have now some height just here, and we know that the volume, so let's just work this out, the volume is given as 1/3 the base multiplied by the height. All we're doing here is working things backwards. So we've already got the volume, that is 40, and this is going to be 1/3 of 16, and I'm going to put it here, 1/3 of 16, and then we're going to multiply this by the value of h which we're looking for. If I multiply both sides by 3, what we've got then is 120 is equal to 16 times by h, or we could just say 16h. So we could say 120 divided by 16 is equal to the height. So we're working this backwards, multiplying both sides by 3, dividing both sides by 16, and this will give us the height. If you want, you can work that out in your head, or you can use a calculator. 120 divided by 16, that will give us our answer, 7.5. So we can say now that the height is going to be 7.5, and the units are centimetres. We've got centimetres cubed, we've got centimetres here, so our answer will be in centimetres. Do check that you have the correct units. So for example, if it said that this was 40 meters cubed, then we would need to make the adjustment. But we've got all of these in the same unit, centimeters. Okay, let's look at one more. A piece of metal in the shape of a square base pyramid of height 10 centimeters and base sides of 5 centimeters is melted down and recast into spheres of diameter 3 millimeters. How many spheres can be made? So this now is a multi-step question, and we need to know the volume of a sphere and the volume of a pyramid. So if we look at a sphere, the volume of a sphere is going to be 4/3. So we'll just write that this is, I'll call this VS. So this is the volume of a sphere, 4/3 pi r cubed. Often this is given in a formula book. If we look at a pyramid, so pyramid, let's jot this in, then we have now the volume, which I'll call VP. The volume of the pyramid is going to be 1/3 the base times by the height. I'm just looking here, and we've got a diameter here of 3 millimeters. That means that we've got a radius here now of 1.5. Just bear that in mind. We've got a formula here that's in with the radius rather than the diameter, and of course the radius is half a diameter. Okay, let's first find the volume of this pyramid. So we'll start off and just show the examiner, if this is an exam question, we know what we do. So the volume is going to be 1/3 the base times by the height. So we can say the volume of the pyramid is going to be 1/3. We've got now the base, which is going to be 5 squared, which is 25, multiplied now by the height, which is going to be 10. So this gives me now that the volume of the pyramid is going to be on here 1/3 of 25 times by 10, which is 250 over 3, and that is going to be now centimeters cubed. So that answer is now the volume of the pyramid. What we've got here now is a diameter of 3 millimeters. We've been working in centimeters so far, so if I write this down, we can write that the sphere, and I'll just jot this in, so that looks like sphere. What we've got then is a radius, which is going to be equal to 1.5, and this is going to be millimeters. So we can say that the radius is going to be now 0.15 centimeters. So that is what we have. So we can convert this now into centimeters. All I'm going to do at this stage is simply divide this quantity here by the volume of a sphere using this as a radius. So we can say the number now, so how many spheres can be made? The number is going to be equal to 250 divided by 3, and we're dividing this by the number of these spheres that will go in. So what we'll have is 4/3 times by pi, which is just a number, times by the radius cubed, and that is going to be 0.15, and we need to cube this answer. So all I'm saying here is I've worked out the volume of the pyramid. and I'm working out how many spheres with a radius of 0.15 centimeters I can fit into here. So all we need to do is put this through a calculator. If you like, you can tidy this up slightly, as we've got divided by 3 in both the numerator and the denominator. You certainly don't have to do this, but this is the equivalent of saying 4 times by pi times by 0.15 cubed. You don't have to do that, you can put the fractions in. So let's go ahead and do that in the calculator. So we're going to have now in the numerator 250, in the denominator 4 multiplied, and we hit shift and pi is down here, and we're going to multiply this by 0.15, which we need to cube, and the answer to this is going to give us 5894.62. So let's write this in. So we've got 5894, and let's write the decimals in, 5894.6. So just jotting this in, 62 dot dot dot. Therefore, we can only make 5,894 spheres. So all I've done is rounded this down, as we don't quite have enough to make the 5,895th sphere, so we've just rounded it down. So quite a more challenging question. We find the volume of the pyramid. We then simply divide this by the quantity that we found here, and that gives us the number. So there we go. That is the volume of a pyramid, square base pyramid, or a triangular base pyramid. We simply take 1/3 of the base multiplied by the perpendicular height.